Alright, so in this video I will start off by talking about the alarms. So here is my alarmable.h. It has a storage map, multi-map, which contains floats as time and alarmable data, which I'll show in a second. It has trigger alarms, a set of registration state, it gets an iterator, it returns a registration state, sets alarms, stops alarms, and all the member functions that go with the alarms associated. And in my game, I only have 4 alarms that you can set. So let's go to the CPP, and here is everything in here. I'm using switch statements with the trigger alarms, getting iterators, setting iterators, getting registration states and setting registration states. And then I'm obviously setting alarms here, and I stop alarms there. So let's look at the alarmable manager. So this is my manager, and it has a timeline map of all of the alarms that were set. So let's go to the manager, CPP. Let's go in here, and this has obviously the process the alarms. Looks to see if it's empty. If it's not, adds a key equals time plus 1, but you don't really want me to explain specific code. So obviously I process alarms, I trigger stuff, I stop stuff. So obviously you can't have an alarm that continues going off. It needs to start and stop at the same time. A deregister and a register for the alarms. Here is the alarmable data. All it is just setting an alarm pointer, and it's getting an enum, which are here for the alarm 0, 1, 2, 3. So the 4 alarms that I let the engine have. So next up is the keyboard input system. So keyboard, well, technically it's all the inputs. So inputable, right here, it has a bunch of, a pressed iterator, a released iterator ID. It has registration status for each. In here, it has a key pressed, a key released. I'm setting input registration states, and I'm registering keys and deregistering keys. So I'll go to the CPP, and I'm basically doing if-else statements for each one to determine if something is pressed or not. Pretty simple. So let's go to the keyboard, and then let's go to the key. I'll do the single key first. So the single key is just for a collection of single keys that are pressed. So it's a list of just the inputables. Pretty simple, and it registers stuff to that inputable list. So here's processing key events if something's released, if something's pressed, registering the key presses and releases, deregistering the key presses, releases, and then the keyboard event manager is a collection of all of these single key event managers created. So obviously I have a register, the inputables, deregister. We'll look at the CPP. Processes all of those. It's registering the managers here into one collection, and indeed registers a collection if needed. And then here are the input event type, obviously key press, key release. So let's go to the collision system. So let's go here, let's go there. Alright, so this is the biggie. So let's start with collidable, and just ignore the empty files, because obviously I had learned through the process that templates can only be everything in a H file. So in the collidable, I have let's see where the interesting stuff is. Collision registration, where I'm registering new collision registration commands. deregistration, registering new deregistration commands. I get a B-sphere, I set a collider model, and I update collision data. So we'll look at the collidable manager first. And this is just a manager of all of the collision test commands, which I'll show in a second. Processes them, cleans them up at the end of the game so that they're not there. Yeah, simple stuff. Set a collision pair, set a collision self, pretty simple. So I guess we could I'll show the visualizer first. So visualizer is a singleton where it is actually creating the seeable collidable B-sphere, so we can tell if something's even colliding. When you when you call a visualizer, it'll create a new wireframe model, which obviously there's built-in model and built-in shader that's called, so the user doesn't have to do that. Also along with the default color. So it has a privately render B-sphere function. It has a submit B-sphere, which I'll show off in a second. And where is my other one? So many comments. Show B-sphere and then visualize all. There we go. So here is the CPP for that. So we have the privately render B-sphere, which is rendering to the camera. Terminate for the pointers, obviously. A visualize all, which renders everything through, like, it's called through the I guess the command pattern for the visualizer. I have show B-sphere, which is calculating all of the matrix data to set up the B-sphere, I guess, itself. And then submit B-sphere is for the command pattern. So we'll go to the volume. This is the collision volume H. It has the intersects, which are not being used yet, but they will be used later on. And then the compute data. So compute data is used in here, in the collision volume B-sphere, and that basically is just setting the center and setting the radius of the B-sphere. Pretty simple. Grouping, collidable groups are here. It's another templated class. It's a singleton. It registers collidable groups to a collection, deregisters them. You can get the collection, pretty simple. And the collision test commands, here's the base class for that, so they could both inherit. And then here is the test pair, so private, public stuff. The execute, where it actually tests the intersection. And then we have the test self, which is testing against itself. And I'll wrap up this video for now because I'm just about to hit my time. So next up will be the game object, life cycle, and sprites.